Hey everyone, how goes it? Welcome back to Computer Science 145. Today, we're going to discuss arrays. Arrays are a very special type of structure. They are a collection of variables all of the same type. Arrays are one of the most foundational data structures, and it's found in most programming languages. You can think of an array as being a contiguous block of memory. The size of an array must be specified initially, again, as it's a contiguous block of memory. But also, arrays cannot be resized. Now, Java treats arrays in a very special way. They are treated as an object type. Now, just like other object types, the identifier of an array only holds a memory address that references the contents. You can think of the reference as it pointing to those contents. So this also means that the double equals, in other words, checking if the values are equals, do not check the contents of the array. It only checks the memory address. Now, as we can see over here, this is the syntax to create an array. We use these square brackets in order to indicate that this is going to be an array of this type. We declare an array much like we declare other variables, but also remember to include those square brackets. In order to initialize the array, in other words, create it, we have to use the reserved word new, followed by the type again, then the square brackets where we have to specify the size right here. Again, arrays are contiguous blocks of memory of the same type. They cannot be resized. You have to initially give it the size in order to create that array. Now, just like other variables, whenever we declare it, we can also assign it at the same time. So you can either use this methodology or this one in order to create an array. Now, as we can see right here, this is an example of creating an array of integers of size 5. Now, taking a closer look at this, let's look at the memory and what happens whenever we are declaring and then initializing an array. Now, once we reach this statement, we understand that this part declares the array. What this does is it creates the identifier, and then the identifier holds the contents. And remember, this identifier right here does not contain the array, it only contains a memory address. The default value for any object type is null, which means it does not exist in memory currently. We have not initialized this array. Now, when we call this part, what this does, using the reserved word new, followed by the type, followed by the size, it creates this structure right here. As you can see, these are 1, 2, 3, 4, 5 different integers created in memory. Now, once again, it's a contiguous block of memory. And as we can see right here, this arbitrarily picked memory address 60, every other integer is separated by 4 bytes. Now, why is that? As we remember, an integer is 4 bytes in memory. So starting from this memory address, as we increase 4 bytes, this is how we can declare 5 different integers all at the same time that are all a part of this data structure called an array. Now, once this array has been constructed, then the identifier that says array is then assigned to the value 60. And this references the start of the array, or in other words, it points to this part of the array. Arrays have a very special property called indices, and an index corresponds to the individual values inside the array. All indices start at 0, and the last valid index is the size, or the length, minus 1. Indexing is how we access and modify elements of an array. Now, as we can see over here, if we needed to access an individual part of the array, we use the array's identifier, followed by the square brackets, and then the index inside of here. Now, if we need to modify a value, we use the array's identifier, the square brackets, then the index, and assign it to some sort of value. Our example over here, this is the first element of that array, and we assign it the value of 1. This is the last element of the array, and we assign it the value 5. But notice, this is the first and the fifth elements. As we always start at index 0, the fifth element is at index 4. Now what we can do is access the individual elements here, array at index 0 and array at index 4, add them together and save them in a different variable. Now this brings up a very important point. The index has to be 0 and the size -1. If we go outside of those bounds, it's going to cause a runtime error called an index out of bounds exception. We have to be very careful not to exceed the bounds of the array in either direction. Now, being able to access and modify these individual values instantaneously is called random access. Now, one way that we can think about how this works, if we're accessing a value, then using that starting address where that array starts, all we have to do is add the index times the size of the type. Random access is the best advantage of using an array because we can instantly access and modify values without having to individually go through every single one of them. Another important property of an array is the dot length. So if we needed to know the size of the array or the length of the array, all we need to do is use the array's identifier and call dot length. So as we can see here, this is another version of assigning the first and the last elements. So we created this array of size 5, and as we know, the first element starts at index 0. Then what we can do is access array.length -1 in order to get the last valid index. As we know, the size of the array was 5, 5 minus 1 is 4, so this is the last valid index. And then this is basically the same code, but just modifying it only slightly to access this last element in a different way. Now, understanding that property, we can further this by saying that a for loop is the array's best friend. So as we know from a previous lecture, a for loop is a counting loop. We initialize a counter from the beginning and update it at the very end. We can use that exact same variable for indexing into every single element into an array. Also, using the dot length, we can use that as the Boolean expression in order to accomplish this. Augmenting the previous example, we see that we have this for loop that's going to assign individual elements of this array. So let's run through this. The first thing that we know in a for loop is we first declare and assign this counting variable that we're going to call I. And as we can see, we've just added that to the memory right there. Now, is I less than array.length? As you can see, array.length is 5, 0 is less than 5, that is true. Next, we enter the body of the for loop. So array at index I, array at index 0 is then assigned to 0. But most importantly, we can access this memory address randomly by calculating. We start at the address 60. We understand that integers are 4 bytes in memory. I is 0. 0 times 4 is 0 plus 60, so that's where we get byte address 60, and we assign this value that was 0 to 0. Then we increase I by 1, and now I becomes 1. Then we check this again. 1 is less than 5, so then we enter the body of the for loop. Now, as we can see right here, array is at index 1 now. 1 times 4 is 4 plus 60, which is 64, which assigns this value here, which is 1, to the value of 1. Then we increase I by 1. Now 2 is less than 5. Array at index 2 is assigned the value of 2. Then we increase I by 1, and now I becomes 3. 3 is less than 5. Then array at index 3 is assigned the value of 3. Increase I by 1, now it's 4. 4 is less than 5. Array at index 4 is assigned to the value of 4. I++. Now I is assigned to 5. 5 is not less than 5. So we jump out of the body of the for loop and we continue on. As we can see here, the for loop and the array go hand in hand. A for loop is a counting loop, and we can simply use this part right here, the variable that we're using to count through it, in order to index into individual elements of this array. Now let's see an example of an array. Let's say we're going to play this following game. I have 5 different contestants, and what they're going to do is guess the price of something closest to it without going over. The item that they're going to be guessing about is Shaq Fu for the Sega Genesis. So now asking each individual contestant what they think Shaq Fu is worth, and let's just assume that this is the loose copy of Shaq Fu, just the game. The first contestant says $13. Next one says $50. Next one, $4. Next one, $1.99, and the last one, $8.99. Now, as of this recording, the cost of a loose copy of Shaq Fu is only $5.97. So which contestant was closest without going over? Well, this contestant right here. Now, let's see an example of this inside of code. So as we can see here, we've already set up the project, so we're going to create a new class to put our code in. I'm just going to name this closest value, include the main method, the entry point. Take out this auto-generated comment, and then put a comment at the top of my code with my name. Now we know we're going to have some kind of user input because we have to provide a means to give those values. So we're going to use the scanner, and we must import java.util.scanner in order to use the type scanner. Inside of our main method, we're going to create a new scanner, name it keyboard, and set it up to read from the console the standard system input, system.in. Now in our example, we had a couple of values that feel like they were constant. First of all, we had only 5 contestants. So I'm going to go ahead and create the constant, public static final int. Size is equal to 5. Now the other constant that we had was the price of the thing that we're guessing. So I'm going to create a public static final. Now I got to think about the type here. It seems to have had decimal values, so that indicates to me I need to use a double. And I'll just call it price and assign it to $5.97. Now, as we had 5 contestants, and what they were providing was individual prices, the thing that tells me is that, wait a second, we have a data structure of all the same type. It makes sense whenever you start recognizing that this is a collection of these items to create a data structure. An array is a foundational data structure, and I'm going to create a double array. And this is indicated by the square bracket. I'm going to name this array prices. Then I'm going to initialize it by calling new, the type double, and then inside of these square brackets, I'm going to put the size. Now, once we've done this, it declares this array of prices, a collection of doubles. This then constructs and initializes a new array of type double given this size. Now from there, we're going to prompt the user. System.out.println. Welcome to the closest without going over game. Guess the price of shack food. Now the next part, what we need to do is collect those prices. We need to individually index into every element of this array and assign those prices. In order to do that, what we're going to use is a for loop. For int I is assigned to 0. We start with this because we know the first valid index in any array is index 0. Now while I is strictly less than prices.length, we're going to increase I by 1 each time. Now in order to make this nice, what we're going to do is prompt the user for the price. System.out.println. Contestant. And what we're going to do is append the value I here. Enter a non-negative price. We're going to go ahead and assume that the price for this thing isn't negative. So I don't think anybody's going to give this to someone and also give them money in order to take it away from them, unless they think the game is that bad. So then after that, we're going to collect this new price. Double new price is then assigned to keyboard.nextDouble. Next, we're going to validate if that new price is correct. In other words, if it's non-negative. So if the new price is greater than or equal to 0, then inside the body of the if, we're going to assign prices at index I is equal to that new price. However, if they did enter some sort of invalid value, we're just going to go ahead and say this. System.out.println, that price is invalid, assigning it to $0. Now we're going to do what we said. We're going to assign prices at index I equals to the default value of 0. Now after we've collected all of those prices, we're then going to prompt the user. System.out.println. The actual price is, and then we're going to append price to this. So now what we need to do is determine which contestant guessed what was the closest price without going over that price. I'm going to accomplish this in this way. I'm going to create a couple of variables. First of all, I'm going to create a double closest price and assign it to something weird. -1. The thing is, we said that the contestant could not enter a negative price. So why are we assigning this to -1 here? Effectively, we're going to use this as a sentinel value, and you'll see why in a minute. Similarly, I'm going to create another variable called int winner index, and I'm also going to assign that to -1. Now, just like the previous variable, -1 is not a valid index. However, this is also going to serve as a sentinel value in order to tell us something. We'll get to that in a minute as well. Now, once we have those variables set up, we need to process every single element of this array. Process is an empty verb. It can mean anything. And what we're trying to do is find the price that is closest without going over. But once again, we need to check every single element of this array. So we're going to use the array's best friend, the for loop. For int I is equal to 0, starting at index 0. I is less than prices.length, I plus plus. This allows us to use that index I in order to check every single element inside of this array. Now we need to check if prices at index I, if this value was less than or equal to the price. So this checks whether or not the guessed price was underneath the actual price. In other words, if it didn't go over. But we're also checking, is this the closest current price? And prices at index I is greater than what is currently assigned to the closest price. Reading out this logic once again, we're checking if this individual price was less than or equal to the actual price. And this price happened to be closer than the closest price that we had recorded yet. By setting this value, closest price, to -1, whenever we find the first price that is underneath the actual price, then this will be assigned. Now, once we find something that is true for both of these, we're going to go ahead and assign the closest price is equal to prices at index I. That is the new current closest price. And also we're going to assign the winner index is equal to index I. And using this logic, we can find the price that is closest without going over. Now, outside of this for loop, what we're going to do is declare the winner. However, there may be a case that was not considered. Once again, we assigned this index to -1, and we're considering that to be a sentinel value. This value is outside the range of what an index should be, and it indicates something very special to us. There might be a case where no one wins. The thing is, if every contestant guessed a price that was over the actual price, then no one wins. So if we went through this entire for loop and didn't find a single price that was underneath it, then the thing is, this winner index would never get reassigned. It would always be -1. So we need to check for that case. If winner index is still equal to -1, then we need to say system.out.println, no one wins. But if that's not the case, then we'll say system.out.println, the winner is contestant. Then we append the winner index with a guess of, then we append the closest price. Now that we have this game written out, let's simulate what we just saw. Running this, welcome to the closest without going over game, guess the price of Shaq Fu. Contestant 0, the first valid index, enter a non-negative price. So they said 13. All right, the next one said 50. Next one said 4. Next one said $1.99. And the next one said $8.99. And as you can see here, the actual price was $5.97, and the winner was contestant 2 with a guess of 4. Now let's also see an alternate version of this. Running this again, let's say that everyone guessed over. So 10, 10, 10, 10, 10. No one won, as everyone went over the actual price. Now to look at this even closer, let's run this in debug mode and look what happens inside of memory. Scrolling up here, we're going to go ahead and add a breakpoint to this line right here, where we're going to create the array. Now, going into debug mode, we start right here. As we can see, we have our memory and we've already created our keyboard scanner. Then the next thing that's going to happen is it's going to declare this array of doubles and then construct this array given this size. Stepping past that, now we have this array of prices, and this says ID 27, memory address 27. We can expand this to see all of the different elements of this array right here, and they're set to the default value 0. Now, entering this for loop, we initialize this int I, which is 0. Then we print this out, and now we're going to wait for this to be entered. And once again, we're going to enter the value 13. So the new price gets assigned to 13, and then this assigns this value to that part right there. So index 0 gets the value 13. Then we increase the I by 1, I++, which makes I 1. Then we print this out. Then we're going to wait for the new price, which was 50. Then we assign new price after checking it to index 1. Then we do the same thing. Contestant 2, now we got to wait for this price, which was 4. 4 is greater than 0, which gets assigned there. Keeps going. I becomes 3. Now we're going to wait for this value. Reset $1.99. This is greater than or equal to 0, so that value gets assigned right there. I gets increased to 4. Now we wait for this value, which is $8.99. Then we step through, assign that value, increase I by 1, which makes it 5, and 5 is not greater than 5, so we jump out of the for loop to right here. Printing out this statement, we now create these two variables, the closest price and the index, which is -1. Now we enter this for loop. We declare the variable I here. Now what we're checking, prices at index 0, is this less than the price, and is this price greater than what the closest price currently is, which is -1? Well, here's the thing. 13 is not less than or equal to this price. So simply enough, we're going to skip that and then increase I by 1. Now index 1, well, this again is not less than the actual price, so we're going to skip that, increase I to index 2. Index 2 has the value of 4. 4 is less than the price, and 4 is greater than -1. So now we enter this for loop, and we reassign the closest price to 4 and the winner index to 2. Increase I by 1. Now we're at index 3. Index 3 has the value $1.99. Now this is less than the actual price. However, $1.99 is not greater than the closest price. So this gets ignored, and then we increase the index by 1. Now we look at 4. $8.99 is not less than the price, so we skip out of that. Increase I by 1, making it 5. 5 is not greater than 5, and so we're outside of this for loop. The winner index is assigned to 2. So this is not true. We jump to the else, and we print out who won. In this lecture, we've introduced this brand new concept called an array. Arrays are foundational data structures, and they're great for grouping together like information of the same type. In the next couple of lectures, we're going to be discussing other ways that we can use arrays. And with all that being said, I'll see you next time.